Hello, I'd like to start my presentation with a short movie. I'm just playing directly.
Hello, my name is Jamshid.
Um, Hello, Jamsheed.
Yeah, I've already shared with my students, and I'm not going to show all of them here, but I would like to show this. You can change subtitles here, you can arrange as Turkish here, and you can watch once in English and once in Turkish. Okay. Then I'm going to go on with my rest of my presentation. Let's find it here. Okay. And our topic is big data. And we have some subtitles here as you see. And we're going to talk about how big is this and what exactly is it, what are the characteristics of it, and where and how is it stored. At least we're going to give some clues about this and how is it processed. And finally, we're going to give some samples. Okay, it's going to be hopefully 10 or 15 minutes presentation. Now, what is big data? As you see in these pictures, photos, let's say, visuals, we produce different types of data with our uh, internet connection and devices. In here we have a mobile device, and almost all of us, almost every day, we produce data, simple data with our messages, phone calls, emails, and pictures, photos, videos, search, and music we listen. A single user uh, produces 40 exabyte per month, and there are some 5 billion smartphone users on the earth. And when we multiply these two uh, values, is really big one. This is just coming from these mobile devices. And we have a picture of a plane here because an average distance, not long distance, average distance, let's say from here to Istanbul, Trabzon to Istanbul flight, produces data as big as two big memory computers. And yeah, this travel, this flight produces, or this plane produces just data of two big computers, hard disk, okay? And before you leave the plane, this data is transmitted to the airport or servers in the airport somehow before we leave the plane. So it's a big data. Can you guess how big is the place they store this data in the airport? Yeah, it's a kind of big data. Everything around us nowadays produces a huge, gigantic amount of data. So, and how big is this data? Okay, according to statistics and guesses, actually in 2020, let's say, global internet traffic was estimated to be more than 3 zettabytes. Zettabytes, what is zettabyte? It is something like that, gigabytes in gigabytes here. So the six zeros are million, billion, trillion, and it is 3 gigabytes. It's very big data. And this is just 2020, 2020, and it grows exponentially. It grows exponentially. It grows very fast, this means. But how big is this? Let's look at here. The zettabytes are here, this gigabyte is here, then we have terabyte, then petabyte, and exabyte, and zettabyte. And we have a comparison here with gigabyte and exabyte. If gigabyte is our Earth, exabyte is the sun. It's million times bigger. I don't know exactly, but at least thousands times bigger than the Earth. But you can make comparison from here. But sometimes these zeros can decisive, and it's easier to compare this value with this physical images. Okay, simply unbelievably big data we produce on the internet traffic. Okay, and we have hard drives of our computers, and hard drives can do nothing about this data. So big data is so big, and it cannot be handled or proceed by our traditional methods. So we need to change in our storage method. Okay, so it's so big simply. And now we should define and restrict this big data. What kind of data is called big data? Okay, in order to call something as a big data, it has got these 5 V's. Okay, in the video it was 4 V without value, but this time there are 5 V's. Okay, characteristics of big data, let's say. And the video I will be referencing at the end of the video, this 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 recording, let's say. Uh, Take health industry all around the world. Health industry, hospitals or other health institutions produces 2.314 exabytes annually. Would you like to see exabyte once again? Here, exabyte is what, million or billion? It's a million times gigabytes or something. Okay, it's a big data simply. Okay, hospitals or health industry produces this much data annually. Annually, there should be two and one U. This is a spelling mistake here, but annually per year. Okay, every year, health industry produces this much data. Okay, so big data, it has got volume. Volume is, in order to, we could say it's a big data, it should be in big volume. And it should have velocity, when you give some samples, it's a blood sample or it can be an X-ray film. Okay, it goes into the system, and even in Turkey, all other doctors can see on the cloud or on the system your values. Okay, velocity means speed or hız in Turkish. Okay, it must have velocity in order to be big data. Okay, and variety, there were different types of data on it. Okay, it should include different types of data. It should include structured data like Excel files, spreadsheets, or something very regular. It goes 1, 2, 3, 4 in a row or something. And semi-structured data. In the short video before this video, we had semi-structured data examples as tweets, Twitter tweets, or our email messages. They've got rows, or it's written. They have got some numbers, and it is semi-structured data. Data sometimes they say. Okay, and unstructured data, simply photos or X-ray scans or something. There are different types of data in it. Okay, and this is veracity. veracity is its accuracy and trustworthiness, reliability, you can say. If you trust this data, if you know that it is true, this is another requirement of the big data. And finally, value. There should be a value of these data. How? But there were 2 point something exabytes data, and you can search through this data and you can find some treatments, you can find some medicines, you can heal people. So this data, this big data, it's very hard to store, it's very hard to process, but it has got value you can find out of this data. Okay, but how to store this big data? Okay, and these are some elements. Simply, it's explained in the previous video, but I'm not going to go into them because it's another topic. It's very complicated topic, but there is something. There is an ecosystem, or so let's say file system. It says okay, program. Let's say it's a part of artificial intelligence, Hadoop. Okay, this process, this storage, okay, it distributes the chunks, the parts of the very big data into different computers. For example, you've got a big data, it includes A, B, and C. Okay, it's distributed different computers. In this computer, A and B stored, and in this computer, A and C stored, and in this computer, C and B stored, and it is 300 megabytes, let's say. Okay, and if you if you if you lose one of these computers, your data is still safe because this is A, B, C is over there. If this computer goes, you still have A, B, C. So, you stored all data twice. Okay. So this is Hadoop distributed file system. Okay, but where are these computers? Okay, there are some these what? Uh, data storage centers, big centers, just for storage, store the data, and there are lots of them around the world. And this is quite like a single computer, maybe more than one. This is another topic. There are some big data centers, and store these data, and you can rent them, you can pay money, and you can use this computer by paying this data center. Okay, so there are big buildings, okay, and they just store data. Okay, and how to process it? Parallel processing made by Hadoop again. Listen, we talked about these big data, and you would like to make an invention out of this health industry big data. You should check, for example, everything about, let's say, coronavirus. Okay, you need to all the information around the world about coronavirus, and you should somehow statistically process it. Okay, and it's big data, it's really big data from all around the world. So you need time to process it. This process sometimes can take months or even years. So Hadoop help us again to divide the process to different computers. Okay, this is a master computer here, and it attains several computers. Hey, computer, do the B. Hey, computer, do the C. Hey, computer, do the D. Or maybe you can use even 30 computers, different computers, and you just process the data coming from all around the world about coronavirus, and then you find the results and analyze it, and you're going to say, okay, if you eat something, for example, olives. Okay, coronavirus is going to, it's not so easy, of course, but you process the data coming from all over the world, and you distribute this task to computers to process. Okay, and some examples. Okay, this is another presentation, this is another YouTube video. I'm going to share the link. Okay, and it's talking about the CERN laboratory in Europe, somewhere in Europe. I don't know where exactly it is. Listen, but they're just making experiments on protons, electrons. I don't know. They just make them hit each other, and they're just recording very high quality micro images, and they produce very enormous amount of what data, since maybe, or for 40 years, maybe more. I don't know exactly, but this data, it's hard to store and process. At the beginning, they were storing this data physically on certain laboratories in big rooms, computer rooms. And then, if you want to make an experiment as a scientist, you should go and visit CERN to make some analysis, to use these data. But then they uploaded everything on the cloud, as we say previously, and distributed into several computers. And it was first in that way. You just collect the data, collect the data, and just collect all together on the cloud all over the world. Then now all the data coming from the CERN laboratories is on the cloud, on the internet, and all the researchers can use this from their homes and analyze this data to find out some uh, scientific results. They just interpret this data, make some statistical experiments or procedures. And another example, there are some two games again from the video I used. So, for example, Call of Duty or other computer games, it's the topic of one of you. And the producers just take the feedback from the computer players. Where do they pause the game? Where where exactly at which point they restart or quit game. They just work on it and improve the game scenarios and user experience, increase the user satisfaction and user increase, and reduces the consumer churn rate. Okay, and people get less crazy while they're playing the game. So, they're always doing that. There are some another experiment about Netflix, for example. They just assess what kind of things people like, and they just use algorithms to recommend or suggest further films to these people. I mean, okay, this is another example. I think it's clear. They're just simply watching the data coming from the players and change their games accordingly. And another example, I was going through just, okay, whatever. In Hurricane Sandy in 2012, they used the tweets, SMS, and other social media things. They just collected and analyzed with the help of the artificial intelligence, and just offered something, and just managed this disaster, and show some recommendations, share some information with the people who are experiencing the hurricane. So it was in the video it was saying that when you analyze and interpret the data coming from the social media, it can be quite useful when you're managing some disasters. Okay, that's it. I'm going to explain in the next video or how can I produce my content and how can I improve the process. See you then.